we are going to have discussion on the linear differential equation with same thing, the constant coefficient only. We were dealing with the constant coefficient only, guys, right? For the constant coefficient we were discussing for the complementary function or the complementary solution, right? Now we are going to start with the particular integral, means pi. What happened, or how we have to find out the pi or the particular integral. So let's have discussion on the pi, dear students. Pi is nothing but the particular integral. Now basically each and everything related to pi depends on this q only, right? Now let me tell you one important thing, dear students. As I already told you, if there is a function f dy, let me write down here. If there is a function of dy is equals to x, then your general solution will contain two parts. The first is CF and the PI. Then only it contains two parts. But if your given equation is in the form of f dy is equals to 0, then your general solution having only and only one part. In that case, the general solution will be of CF only, guys, right? So we already discussed these type of cases. Now we are going to start with the pi, and after pi there are 7 cases for pi. After completion of pi, I will show you mixed questions where we have to find out the general solution with in the form of CF and pi both, right? So let's start, dear students, here. So it's a simple thing. Now let's start here. What exactly pi depends, or pi is an important thing, okay? And pi is depends on only and only this factor q, right? If you have differential equation in the form of this one, f dy is equals to q, then you will write down pi is equals to 1 by fd into q, dear students. When it will happen, each and every cases will vary from by the q only, right? So each and everything related to q will be varying from here, okay? So let's approach. So exactly here the conditions will be changes only and only of q, because fd will be same. Fd means the differential equation is of the is in the form of d only, and we have to change only and only q. So each and everything depends on this q only, okay? Now let's start with the case number 1. If your q, let's start with the case number 1, dear students. If your q, okay, if your q is equals to e to the power x, e to the power ax, if q is equals to e to the power ax, then we have to find out the pi. In that case, what will happen to the pi, how we will find out the pi, okay? Let's have discussion. So in that particular case, you will say f dy is equals to e to the power ax. Yes, exactly. So hence your pi will be 1 by fd into e to the power ax. Now just remember this thing, your pi will be 1 by fd into e to the power ax, okay? How it happens? 1 by fd into e to the power ax will be your pi, okay? So remember one thing, whenever we have q in the form of e to the power ax, we can directly approach at the place of d in the given function, we can directly approach a, means we can replace d by a only in the given function. Means it will become, when we approach it, it will become, or the exact pi will be 1 by f of a into e to the power ax. 1 by f of a into e to the power ax, if and only if f of a is not equals to 0. Is it clear, my dear students? Means exactly I was showing you the each and every step. So the pi, the question will be in this form, then you will write down 1 by fd into e to the power ax, then you have to apply e to the power ax on this function of d only. So when we apply e to the power ax on this function of d, it will become, we can replace d by a only. At the place of d in the given equation, we can replace by a, right? When we replace by a, it will become 1 by fa into e to the power ax. Clear, guys? So this will be the pi only, and it's only and only possible when f of a is not equals to 0. If your f of a is equals to 0, it's not at all possible to approach, right? I will tell you if f of a is equals to 0, what happened, I will tell you. That will be our case number 2. So right now I think you are getting my point. The case number 1 is only and only thing whenever we have q as a e to the power ax, when we have a q as a e to the power ax, we can replace in the given function of d by a only. So the complete function will become of f of a only, guys. So and its only and only condition is f of a should not equals to 0. Okay, now let me write down one example for this one so that it gives you more clarity, guys. So I have one example. One by, suppose I have a question, find the pi means the particular integral for the function for the equation d square minus 3d plus 2y, d square minus 3d plus 2y is equals to e to the power 3x. Let's approach it. How it will become? So we will change, find the pi, we have to find out pi only. So pi will be 1 by d square minus 3d plus 2 into e to the power 3x only. Yes, exactly. So as I already told you, we have to just replace each and every d by a only. A is what? E to the power ax, right? So here you can see a is equals to 3. You can see here a is equals to 3, guys. Yes, so we can replace d by a. So we can put d is equals to 3 in the given equation. Yes, when we put, it will become d square, it means 3 square. Yes, minus 3 into 3. Yes, plus 2. Yes, exactly, into e to the power 3x. We already having 3 square is 9, minus 3 into 3 is 9. So this 9 and 9 will be cancelled out, hence we will get 1 by 2 into e to the power 3x only. Yes, exactly. So this will be the final solution, dear students. Yes, exactly, this will be the final solution. So this is the pi for this type of equation. I think you can easily identify, you can easily approach the things how we will go for this one. Okay, if we have e to the power ax form, just remember one thing, dear students, your function, just the important thing is that your function f of a should not equals to 0. If f of a should not equals to 0, then we can directly write down at the place of d a. Okay, d at the place of d we can write down a, or here we have a is equals to 3. So when we substitute, we get 1 by 2 into e to the power 3x. Done. So this is a very simple form. Now what happened? This is the first form, right? Case number 1. Now what happened when we have as f of a is equals to 0, then what we will do in that particular case? Okay, so let's have discussion on this one, dear students. So the next case is for e to the power ax only. Again, this case is again for e to the power ax, means if the question in the form of f dy is equals to e to the power ax, then you will write down the pi will be 1 by f d into e to the power ax. But here f of a is equals to 0. When here f of a is equals to 0, what happened to the pi? How the pi will changes? Let's have discussion. So when it's equals to 0, dear students, you will differentiate this one to e to the power ax. When you will differentiate, it will be x by f dash a into e to the power ax. It's possible when f of a is equals to 0. X by f dash a, x by f dash a into e to the power ax, right? So we will convert this equation in this pi in this form. So this pi will be x by f dash a into e to the power ax if f of a is equals to 0. Now suppose again if f dash of f dash a is also is equals to 0, then what happened to the pi? Let's have discussion here only now. If it's again equals to 0, you will write down here x at the place of x, it will be x square, double derivative of f dash a, it will be f double dash a into e to the power ax. It's possible when your f dash a is also is equals to 0. Is it understandable, dear students? It's a very simple thing to understand, right? So we will have these two cases. Suppose if double dash a is also 0, then we will go for x cube by f triple dash a into e to the power ax. Then in that case f double dash a will be equals to 0. Clear? So we can proceed directly. Okay, so here what is f of a, that you know very well. F of a or f dash a or f double dash a is nothing but the substitution, we replace d by a in the given equation only, right? So it's a simple thing to approach. This is the case number 2 and it's a simple, dear students. Let's have discussion on an example based on this one. So it's not necessary it's stop here. It can proceed so on, right? So we can go for it. Okay, now let me write down one or two example based on this one. Let's have discussion on first example. It is find the pi of the equation, find the pi of d square minus 3d plus 2 y is equals to e to the power 2x. Now in that case, if we have to find out the pi, what we will write down? We will write down pi will be 1 by d square minus 3d plus 2 into e to the power 2x. Yes, exactly, it will be. Now what happened to this one? When we approach it, it will become okay. Let's check here. First of all, f of a, it means f of 2 is equals to what? Okay, when we approach here, it will be dear students 2, it means 4, right? Minus 3 into 2 is 6 plus 2. You can easily see it is 6 minus 6, which is equals to 0. So you can say here f of a is equals to 0, right? Or f of 2 is equals to 0. Exactly. So we will approach by the case number 2 only. Case number 1 it will not work here. So it will be 1 by the differentiation of this one. It's not 1. Let me write down with the different color. Yes, so it will be pi is equals to x by f dash a. F dash a, it means it will be the differentiation of this one. It will be 2d minus 3 into e to the power 2x. Let's approach here. It will be 2 into 2. The value of d or the value of a is equals to, the value of a is equals to 2 only, minus 3. So it will be 2 into 2, that is 4. 4 minus 3 into e to the power 2x. So it will be x into e to the power 2x will be your final answer. Is it clear, guys? What we approached here? We approached here pi will be x by f dash a into e to the power ax, right? So we approached here pi will be x by f dash a into e to the power ax. Clear, guys? So it's a simple thing to approach. We can easily go with this one. Let's have discussion on one more example. Let me write down one more example for you. So if the pi is in the form of d square, find the pi for the equation d square minus 2d plus 3 minus 2d plus 3y is equals to e to the power 3x. Suppose if we have an equation like this, then what will happen to this one? When we approach this one, what happened to this one, dear students? Let's approach pi is equals to 1 by d square minus 2d plus 3 into e to the power 3x only. Here you can see, dear students, directly when we approach f of 3 is equals to 0. How? Because when we approach d square is equals to 3 square, that is 9, minus 3 into 2 is 6 plus 3, so it will be okay, 2 into 3 is 6. Okay, so d square, I think it should be minus 3. I think it should be minus 3, guys, right? So yeah, exactly, it should be minus 3. Now we can approach, it should be minus 3. Now we can approach, it is equals to 0. So when it is equals to 0, we will differentiate or we will approach with the help of the same method which we discussed right now. So the pi will be x by 2d minus 2 into e to the power 3x. It will become x by 2 into 3 minus 2 into e to the power 3x. It will become 6 minus 2 means 4 e to the power 3x. Okay, clear, guys? So we can approach just like this. So it's a simple thing to approach. Let's have discussion on one more example, so that where you have to differentiate 2 times. So the find the pi of d power 4 minus 2d cube, d power 4 minus 2d cube plus 2d minus 1, d power 4 minus 2d cube plus 2d minus 1 into y is equals to e to the power x only, right? Yes, e to the power x only. So when we approach it, it will be, the pi will be 1 by d power 4 minus 2d cube plus 2d minus 1 into into e to the power x. When we approach here means f of a, that is equals to f of 1. It will be 1 minus 2 plus 2 minus 1, so it will be 0 only. Yes, exactly. So we are having it as a 0, so it means we have to differentiate this one. So when we differentiate this one means this is the question, this is the case number 2 question, right? So when we approach it, so it will become pi is equals to x by f dash d. It will be 4d cube minus 6d square plus 2 into e to the power x. Okay, now let's check it again. So when we approach here, f dash of a means f dash of 1, it will be 4 minus 6 plus 2. We can clearly see again it is 0 because 6 minus 6 is equals to 0 again. So we will approach it again, guys. When we approach it, it will be pi is equals to x square by 4d cube. It means it will be 12d square minus 12d, guys, right? So 12d square minus 12d into e to the power x. So here we have to approach 1 only, so it will be, when we approach it, it will be again 0. You can clearly see here, dear students, it's again 0 because when we approach here 12 minus 12, it is equals to 0. It means we have to differentiate it one more time. So this is the case where we differentiate 1, 2 and 3 times. Let's have discussion. The third case will be, okay, let me write down here only with the different pen. Yes, so it will be the pi will be x cube by 24d minus 12, right? It will be x cube by 24d minus 12 into e to the power x. So when you approach it, it will be x cube by 24 minus 12. It will be 12 into e to the power x. Now finally this will be the final answer because here a is equals to 1 only, guys. So when we approach, it will be x cube by 12 into e to the power x. Clear? So I think you are getting my point how we can approach with these two cases. I don't think that you have any doubt, dear students, because in the PI exactly the cases are 7, but so many students got confused up to the case number 7, right? So I think let's have discussion. Case number 1 is simple. When we have q as e to the power ax, we have to replace d by a only, right? It's a simple thing. When it's only possible when f of a is not equals to 0. When f of a is equals to 0, we will go for the case number 2. So if it's equals to 0, we will go for x by f dash a into e to the power ax. If f dash a is again equals to 0, we will go for the next one, x square by f double dash a into e to the power ax. If it's again 0, f double dash a is also 0, we will go for the x cube by f triple dash a into e to the power ax. Okay, guys, now let's come to the case number 3. So what happened when we have a sine or cos function? What happened to the pi when we have a cos or sine function? It means when we have a equation 1 by fd into sine of ax form, or we have a 1 by fd into cos of ax form. How we will approach it, guys? In that particular case, if you have to find out the pi for these cases, what happened to this one? You have to replace f of let me write down here, just replace d square by minus a square. Remember the thing, it's not minus a whole square. Just remember, it is not minus a whole square, it is minus a square, right? Okay, so you have to replace wherever in the given equation d square is come, okay, d square is there, you can replace that d square by minus of a square. Okay, so it's only and only possible when we have f of minus a square should not equals to 0. It's only possible, guys, when we have f of minus a square is not equals to 0, right? Remember the thing, when it's equals to 0, it will not approached. Okay, it will not approach, guys. So the result is 1 by fd into, okay, the question is 1 by fd into sine of ax, or we have 1 by fd into cos of ax. Then we can directly approach, my dear students. Okay, and we have to just replace d square by minus a square only. It is possible when f of minus a square is not equals to 0. Okay, Now let's have discussion on the question based on this one. Let me show you an example based on this one. Do we have? Yes, we have. So find the pi of, question is again, find the pi of d square minus 3d plus 2, d square minus 3d plus 2 y is equals to sin x. So when we have to find the pi of this case, what happened to this one? So the pi will be 1 by d square minus 3d plus 2 into sine of x. So as I already told you, whenever we have a function 1 by fd into sine of ax or cos of ax form, we have to replace d square by minus a square only, right? So remember that concept only. So when we approach here, you can see a is equals to 1, so you have to put at the place of d square minus 1 only. So when you put here, it will become, dear students, 1 by d square, it will be minus 1. Now remember one thing, you have to put only and only at the place of d square. You will not put at the place of d, okay, remember that point. So we will approach only and only at the place of d square. The d will be unchanged, it will be same, okay, and it is sin x. So when we approach it, it will be 2 minus 1 means it will be 1 only. So it will be 1 minus 3d into sin x. Now what happened to this one? We have to remove this d, dear students. We have to remove this d. So how we can remove? Because in the form of sine or cos, if there is a form, just remember my thing, okay, just try to understand the thing. If there is a form including only and only 1 by 3d, then we can approach it easily that it is nothing but the integration of sin x. But here we are having 1 minus 3d. So how we will approach? We have to remove this 1 minus 3d, means we will remove this d from the denominator. We will remove this d from the denominator. For removing this, we will do the rationalization. Let me show you how. So your pi will be 1 by 1 minus 3d into sin x. So we will rationalize this one. So it will be 1 minus 3d, it will be 1 plus 3d divided by 1 plus 3d into sin x. So when we rationalize this one, it will be 1 plus 3d as it is. As we know very well, this is nothing but a minus b and a plus b, which is equals to a square minus b square, guys. So it will be 1 square minus 3d square only. It is equals to sin x only. Yes. So when we approach it, 3d square. Now again we can approach at the place of d square, we can write down, dear students, minus 1 only. At the place of d square, we can write down minus 1 again. Yes. So we can write down it as 1 plus 3d will be here. 1 square is 1 only, minus 3d square will be minus 1 only. When you approach, it will be sin x. So it will be minus minus plus 3. So hence it is 1 by 4. We can just separate 1 by 4, and here we have to approach 1 plus 3d on sin x only. So it means we have to multiply sin x by 1. So when we multiply sin x by 1, it will be 1 by 4 into sin x only plus 3 into d of sin x. D of sin x means, dear students, we have to find the derivative of sin x. Yes, exactly. So it will be 1 by 4 sin x will be here only, plus derivative of sin x is cos x only. Hence this will be the final answer. This is 3. Hence this will be the final answer. Dear students, is it clear to everyone? Are you getting my point? Yes. No. We did a mistake, dear students. Here it will be a square minus b square. So it will be 3 square, na? It will be 9. Okay. It will be 9 here. So hence it will be 9 here. So it will be 1 plus, where it is 1 plus 9. So it will be 1 by 10 only. It will be 1 by 10 only. Hence it will be 1 by 10 only. It will be 1 by 10 only. Okay. Yes. Now it's clear, I think. So 1 plus 3d. So we will have 1 by 10 into sin x plus 3 cos x. This is the final answer, right? Because we approached here a square minus b square. So a square is 1 only, b square is 3d square. 3 square is 9, and at the place of d square we put here minus 1. Is it clear? let me write down here 3 square into d square. 3 square is 9 only. At the place of d square we put here minus 1. That's why it will be 9 into minus 1. Hence it is minus minus plus 9. So 1 plus 9 which is equals to 10. Okay guys, clear? So we can approach like this only when we have a function. When we have a function of sin x and cos x form, we can approach like this only, dear students. Yes, exactly. Okay.